Our solar system is a place of incredible diversity. It's filled with planets of different sizes, colors, and compositions. But among these celestial wonders, Mercury stands out as a truly unique and enigmatic world. As the closest planet to the Sun, Mercury experiences the full force of our star's immense energy. It's a place of extremes, with scorching temperatures during the day and frigid cold at night. Its surface is a barren landscape, heavily cratered and ancient. Yet, despite its harsh conditions, Mercury holds many secrets that continue to intrigue scientists. Mercury is the smallest planet in our solar system, even smaller than Jupiter's moon Ganymede. But what it lacks in size, it makes up for in speed. As it whips around the Sun at an average speed of 107,082 miles per hour, Mercury completes an orbit in just 88 Earth days. This rapid journey, coupled with its close proximity to the Sun, makes Mercury a fascinating subject for astronomers studying the dynamics of our solar system. Mercury's orbit is not a perfect circle. Instead, it follows an elliptical path, which means its distance from the Sun varies throughout its year. At its closest point, known as perihelion, Mercury comes within 29 million miles of the Sun. To put that in perspective, Earth orbits at an average distance of 93 million miles. This close proximity means that Mercury receives an incredible amount of solar radiation. At perihelion, the Sun's rays are over 9 times more intense on Mercury than they are on Earth. This extreme heat is one of the defining characteristics of this enigmatic planet. At its farthest point, known as aphelion, Mercury is about 43 million miles from the Sun. This variation in distance, combined with Mercury's short year, means that the planet experiences significant changes in temperature throughout its orbit. These temperature swings, coupled with the intense solar radiation, make Mercury a hostile environment for life as we know it. Without a substantial atmosphere to moderate temperatures, Mercury experiences the most extreme temperature swings of any planet in our solar system. During the day, the Sun's rays bake the surface, sending temperatures soaring to a scorching 800 degrees Fahrenheit, or 430 degrees Celsius. This intense heat is hot enough to melt lead. As soon as the Sun sets, however, temperatures plummet to frigid lows of minus 290 degrees Fahrenheit, or minus 180 degrees Celsius. This dramatic temperature difference is due to Mercury's lack of a substantial atmosphere. On Earth, our atmosphere acts as a blanket, trapping heat from the Sun and distributing it around the planet. Mercury's thin atmosphere, known as an exosphere, is not thick enough to retain heat, so the surface rapidly cools once the Sun goes down. This extreme temperature variation is one of the most striking features of this enigmatic world. At first glance, Mercury might appear quite similar to our own moon. Its surface is heavily cratered, a testament to the countless impacts it has endured over billions of years. These craters range in size from small, bowl-shaped depressions to vast impact basins hundreds of miles across. The Caloris Basin, one of the largest impact features in the solar system, stretches over 900 miles across Mercury's surface. This colossal crater is a testament to the violent collisions that have shaped Mercury throughout its history. Between these craters lie vast plains of smooth volcanic material. These plains suggest that Mercury experienced a period of intense volcanic activity early in its history. Volcanic eruptions would have spewed molten rock across the surface, filling in older craters and creating the smoother plains we see today. Scientists believe that these volcanic plains are younger than the surrounding cratered terrain, providing a glimpse into Mercury's dynamic past. Days of sunlight, nights of frost. Mercury's unique rotation. Mercury has a very slow rotation compared to Earth. It takes 59 Earth days for Mercury to rotate once on its axis, which is actually 2/3 of its orbital period. This means that for every 2 orbits around the Sun, Mercury rotates 3 times. This unique 3-to-2 spin-orbit resonance is due to the gravitational influence of the Sun on Mercury's rotation. This unusual rotation pattern has a profound effect on Mercury's day-night cycle. A single day on Mercury, from sunrise to sunset, lasts for 176 Earth days. This means that a day on Mercury is actually longer than its year. During this extended day, the Sun appears to move across the sky in a strange, looping pattern. This is because Mercury's orbital speed varies throughout its year, causing the Sun to appear to speed up and slow down in the sky. A sun like no other, the view from Mercury's surface. Imagine standing on the surface of Mercury. The sun would dominate the sky, appearing over 3 times larger than it does from Earth. Due to the lack of a substantial atmosphere, the sky would be black even during the day, with the stars shining brightly against the darkness. As the sun slowly traverses the sky, its intense heat would bake the surface around you. Shadows would be sharp and well-defined, and the craters and mountains would cast long, eerie shapes across the barren landscape. A tiny dynamo, Mercury's magnetic field and iron heart. Despite its small size, Mercury possesses a global magnetic field. While much weaker than Earth's magnetic field, its presence is surprising. Scientists believe that planetary magnetic fields are generated by a dynamo effect, which requires a molten electrically conducting core. Observations suggest that Mercury has a large, solid iron core that makes up a significant portion of its interior. This iron core is thought to be at least partially molten, allowing for the generation of a magnetic field. The presence of a magnetic field on Mercury has important implications for understanding the planet's internal structure and evolution. A history of observation, from ancient stargazers to modern probes. Mercury has been known to humans since ancient times. Its close proximity to the sun makes it a challenging object to observe, but ancient astronomers were able to track its movements across the sky. The ancient Babylonians associated Mercury with their god Nabu, the god of wisdom and writing. The Greeks gave Mercury 2 names, Hermes, the messenger of the gods, when it appeared in the morning sky, and Apollo, the god of the sun, when it appeared in the evening sky. The invention of the telescope in the 17th century revolutionized our understanding of Mercury. Galileo Galilei was the first to observe Mercury through a telescope, although his observations were limited by the technology of the time. In the centuries that followed, astronomers used increasingly powerful telescopes to study Mercury's surface, rotation, and orbit. A surprise in the shadows, the discovery of water ice on Mercury. One of the most surprising discoveries about Mercury came in the late 20th century when radar observations revealed the presence of water ice at the planet's poles. This might seem counterintuitive given Mercury's proximity to the sun, but the planet's axial tilt, or obliquity, is almost 0 degrees. This means that the poles are permanently shadowed, never receiving direct sunlight. Within these permanently shadowed craters, temperatures remain incredibly cold enough for water ice to exist for billions of years. The discovery of water ice on Mercury has profound implications for our understanding of the distribution of water in the solar system and the potential for finding resources for future space exploration. Unlocking Mercury's secrets, ongoing exploration, and future missions. Despite its harsh environment and challenging observational conditions, Mercury has been the target of several successful space missions. NASA's Mariner 10 spacecraft, launched in 1973, was the first to fly by Mercury, providing the first close-up images of the planet's surface. NASA's Messenger, or Mercury Surface Space Environment, Geochemistry and Ranging spacecraft, launched in 2004, spent 4 years in orbit around Mercury, mapping its surface in unprecedented detail and gathering a wealth of data about its composition, magnetic field, and exosphere. Currently, the European Space Agency's BepiColombo mission, launched in 2018, is on its way to Mercury. BepiColombo consists of 2 spacecraft that will orbit Mercury in tandem, studying its interior, surface, magnetic field, and exosphere in even greater detail than Messenger. These missions, along with future planned missions, will continue to unlock the secrets of this enigmatic and fascinating world. As we continue to explore Mercury, we gain a deeper understanding not only of this unique planet but also of the processes that have shaped our solar system as a whole. Mercury, despite its small size and harsh conditions, holds valuable clues to the formation and evolution of planetary systems, reminding us that even in the most extreme environments, there is always more to discover.